is balancing chemical equations. This is based on the law of conservation of matter, the fact that any atom that we have on the left side, on the reactant side, has to come out on the product side. So we can't just have matter coming out of nowhere or just simply disappearing. This is going to be built on our atomic accounting, which we did in our last lesson. So step one, we have to count how many atoms of each element are on either side of the equation. So what I do is I make this thing called a balancing table, put my reactants on the left, my products on the right. And I like to line this up somewhat with my little dividing arrow right here that just kind of helps me visually see the difference between these. Then I fill in each individual element that I have. So I have silver, nitrogen, oxygen, magnesium, and chloride. Some people ask, can you keep the NO3 together since it's a polyatomic ion? There are times when you can do this, and sometimes it'll work fine, but there are times when it doesn't work, so I don't like to get you in that habit. So let's go through and count. We have our 1 silver right here, 1 nitrogen right here, 3 oxygens, 1 magnesium, 2 chlorines. Jumping over to the other side, 1 silver, 1 chlorine, 1 magnesium, 2 nitrogens, because that 2 is getting distributed, and 6 oxygens, because 2 times 3 is 6. So step 1, we counted everything we have. Step 2, we're going to see what elements are not balanced. So if they're not equal on both sides, they are not balanced. So I'm just going to put a little mark by any that are not balanced. Silver, 1 and 1, balanced. Nitrogen is not balanced right now. Oxygen is not balanced right now, and chlorine is not balanced right now. Now the next thing we have to do really becomes a little bit of trial and error. We are only changing coefficients. You can't change these little tiny subscripts. They actually have to do with how things are bonded, and we're not allowed to mess with that. However, we can add groups of things to this equation to balance it out. So get a little trial and error here. We're just going to find something to try. If it doesn't work, we can always redo it. We can go back. We can start again. So I'm going to start by looking at, chlorine. I think that's a good thing to look at first. So on the left side of my equation, I have 2 chlorines. On the right side, I have 1. This tells me I need more chlorines over here. So in order to get more chlorines on the right-hand side, I'm going to go ahead and put a 2 right here. So I'm allowed to put a coefficient in that blank. Now what that's going to do, it's going to change so I now have 2 silvers. Since 2 is affecting everything that's following within that term, it's kind of like if you have this in math, it goes to everything in that parentheses. However, if you do have this in math, then you have this plus sign over here, the 2 would not go to that 5. So the 2 is kind of done after AgCl. So it does change my amount of Cl to 2. So I've now balanced out my chlorine, which is great, but unfortunately I threw off silver. That's okay though, because I still need to fix nitrogen and I still need to fix oxygen. If I look at my silver, my nitrogen, and my oxygen, what you're going to notice is you need more of all of those things on the left-hand side. So the next thing I'm going to try to do is I'm going to go over here where I see silver, nitrogen, and oxygen. I'm going to put a 2 in front of that. That's going to change this guy to 2. That 2 distributes to the silver, it distributes to the nitrogen, and it's distributing to the oxygen and to that 3. So 2 times 3 gives me 6 oxygens. So now what I can do is I can go back through and double check how I've done. Now I'm going to check things off if they balance. 2 and 2, 2 and 2, 6 and 6, 1 and 1, 2 and 2. This equation is balanced. The last thing I want to do is make sure my coefficients are in the lowest whole number ratio. This is 2. My coefficient in this term is actually an invisible 1. Coefficient in the next term is 2. And my coefficient in the last term is 1. 2 to 1 to 2 to 1, whole number ratio. Lowest whole number ratio. So let's try this guy. We've only got Li and N here. I'm going to start by counting them. 1 lithium, 2 nitrogens on the left. Over on the right side, 3 lithiums, 1 nitrogen. So I can really start pretty much anywhere here. I do need more lithiums on the left side. So I'm going to start by just seeing what happens if I throw a 3 right here. change that to a 3. Now I fix that. Now I got to fix nitrogen. So in order to fix nitrogen, the problem that I'm going to run into is I need more nitrogen right here. If I put a 2 there, changes that to 2, but what does it do to lithium? Turns lithium into a 6. So you may be like, oh no, what do I do now? Well, I can go back over to the other side and get rid of my 3. And since I want 6 lithiums, I'm just going to put a 6 there. So there's actually another way you can do this, depending on how you look at it, where you might not have had to change lithium. That's okay, though. You can do this with trial and error. It's not a big deal. 6 is balanced, 2 is balanced. My total fissions are 2 to 1 to 2. That's a lowest whole number ratio. So I've got Al, Fe, and O. One thing that's kind of nice here when you're looking at these, so we've got 1 aluminum, 3, 4, 2 aluminums, 3, and 1. Some people start to notice that there are certain patterns here. For example, because you have a 4 here and a 3 here, your number of oxygens has to be a multiple of 4, and it has to be a multiple of 3. So how many total oxygens do you think you're going to end up with? Think about your lowest whole number, or your lowest multiple of 4 and 3, which hopefully you know is 12. So you're probably going to aim for oxygen to come out as 12. So in order to make this oxygen 12, I put a 3 there. That would change iron to 9 and oxygen to 12. If I put a 4 over here, it changes aluminum to 8 and changes oxygen to 12. Now, if you didn't follow what I was just saying about common multiples, it's okay. You can trial and error this one. It's really not a big deal. It might just take you a second longer, but you'll still get there. Now we fixed our oxygens. Our aluminums are still off. I have 8 aluminums on the right. To get 8 aluminums on the left, easy peasy. I just actually stick an 8 there. I need 9 irons on my product side. Easy peasy. Since they're in a terminal by themselves, they're really easy to change. So we got 8 and 8, 9 and 9, 12 and 12. 8 to 3 to 4 to 9. Higher numbers than our last example, however, they're still a lowest whole number ratio. This is a more complicated example. We got a lot more going on here. So we got carbon, hydrogen, and oxygen. What sometimes helps us to identify, this is a combustion reaction, if you remember. Combustion reactions, it's tough to balance oxygen or hydrogen first, mainly because you have oxygen in multiple terms here. Hydrogen can be a little tricky. Oxygen, you really don't want to do first. I recommend doing carbon first. So we got 8, 16, and 2. Over here we got 1, 2, and 3. Be careful. 2 here, 1 here. They all add up to a total of 3 on our product side. So in order to balance carbon, what I would do first is put an 8 right here. Changes that. Now I have 16 oxygens here and 1 here. So I have a total of 17. What you might be noticing is that's going to be problematic because of this 2. Because we have a 2 right there. So we are going to need to end up with an even number of oxygens, which kind of complicates things a little bit. So we got to go back to the drawing board a little bit. Hydrogen's still totally screwed up right now. So if we went next and we tried to actually balance this hydrogen out, we'd realize that we have to put an 8 right here. When we put an 8 right there, that's going to change my hydrogen to 16, which works perfect because it balances that. This 8 is going to go to this oxygen, plus we still have this 16 over here. So we're actually going to have 8 plus 16 oxygens, which gives us a total of 24. So now if we actually look back to the drawing board, things have kind of gotten cleaned up quite a bit. So by starting with carbon, it looked really messy for oxygen for a minute. We do need oxygen to come out even. Is there a place right now where you could fix just oxygen? You could do it right here. So because we need to end up with a total of 24 oxygens, we can go ahead and put a 12 right there. So this is kind of complicated, but we've got 8 carbons right here, 8 carbons right here, 16 hydrogens, 16 hydrogens, 24 oxygens, 8 oxygens plus 16 oxygens gives us 24. Everything's balanced. Our ratio 1 to 12 to 8 to 8. We're all balanced up and looking good. So go ahead and try this on your own, and I'll walk through it in just a moment. So we've got CA, SO, AL, and F. 1, 1, 4, 1, 3, 2, 3, 12, 1, 2. So when I'm looking at this, what kind of sticks out to me is that on one side, I have a couple coefficients here. So I have like this 3 here and this 2 here attached to those F's. That really jumps out at me to tell me that I'm probably going to need a 2 here, and I'm probably going to need a 3 here. So what that's going to do for me is turn this into a 3, and this into a 6, this into a 2, and this into a 6. So that actually kind of cleaned up my aluminum and cleaned up my fluorine. Now I have to deal with my calcium, my sulfur, and my oxygen. So because I have 3 calciums over here and only 1 over here, that tells me to plop a 3 right there. Turns that to 3. This distributes through, so it goes to the S, goes to the O, which means that's going to become a 3, and that's going to become a 12. 3, 3, 12, 2, 6. Our ratio is 3 to 2 to 1 to 3. We are good to go. Now, another thing that we might have to do is determine the sum of the coefficients in a reaction. So go ahead and pause, take a minute, and balance this. So let's get this all balanced. You get 4, 3, 2, and 6. Remember, we need to make sure these are lowest whole number ratio, which they are. They ask you to sum the coefficients. You do 4 plus 3 plus 2 plus 6. I've seen this question before, so I just want to draw your attention to it. In this case, it equals 15. You do have to be careful on one like this. The sum of these coefficients is actually 3 plus 2 plus 1 plus 3. You can't forget about that 1. So this would be 5, 6, 7, 8, 9. So pretty straightforward. Just wanted to draw your attention to that possible question. And that completes balancing equations. Next, we'll look at how you determine if something is missing from a reaction.